Slide is visible.
Yes, sir, visible.
I think if Zabira join, I have include some doubt that previously he have asked to me that.
Okay, sir. She said she would join soon, so you can continue. At the end of the session, you can clear the doubt if she arrives.
Okay, okay. So, from your side, any doubt in the quiz or that anything that M. Mishra, Shyamlal,
No, sir, the quiz is fine. There's no doubt in quiz.
any difficulty in that course content or anything, video or that YouTube video transcript?
There is some question regarding photolithography process. So
Okay.
I will ask later. Uh,
No, no, you can ask to me that, no problem. If I able to answer you that, it is very, I am very grateful for.
okay, okay, sir.
What is your
So
doubt?
may okay regarding etching process and PVD, CVD, this type of process. Uh,
Itching.
yeah, etching.
So what your doubt in itching?
Uh, there are two types of positive and negative. Sorry,
Yes,
there are
positive.
different types of.
There.
Yes, sir. So if you tell me uh, very deeply, then it's better because I don't understand
Regarding
from the
positive
lecture.
and negative photoresist.
Yes, sir.
So it is like that. It is just a type of material.
Yeah.
Okay, I will take that. Suppose that this is your SI substrate, any substrate, glass or silicon or like that. Okay.
Okay. Okay.
So in the photolithography, what you have to transfer your pattern, your image or your design. Okay.
Yes.
Suppose you
Mm.
want to fabricate CMOS. CMOS, you have the source, drain, and gate. Okay.
Okay. Sir.
And CMOS have two channel, one P channel and P type, one N channel will be there. Okay.
Yes. Yes, sir.
So now we want to like that. This is my silicon substrate. Here I want to create P. Here I create N. Above that I want to create here gate. Either there is a then there is a source. This type of structure you have to see.
Yeah.
Okay.
Yes, sir.
And this is the channel. Okay. Now
Yes, sir.
in fabrication, how you create this type of design? Okay. Suppose
Yes, sir.
this is the rectangle strip. Suppose Malo, this is the rectangle strip, source and then or circular, whatever pattern you want to transfer as per your convenience, you can transfer as per your design. Like that, have you wear the printed T-shirt?
Yes, sir.
Printed T-shirt.
Yes, sir. I have.
Like that, in the IIT, there is a culture like that. Some IIT Guwahati printed T-shirt logo, your name will be
Yeah.
printed
Yeah.
on the T-shirt. Okay.
Yes, sir.
So how they will be transfer that your name on the T-shirt?
Uh, through different type of printer, maybe,
Yes,
which can
printer will
print.
be there. They have to make the design in the printing or die.
Yes, sir.
They have to make the die, and they have just fill the color in the die and just they put die on the T-shirt and they just paste it on that T-shirt.
Yes, sir.
Same like that, we have to make the mask. Okay,
Yes, sir.
in mask that we have the design which we want to transfer on our device, our substrate. Okay,
Okay.
so
Yes, sir.
to transfer that design, we need a photoresist because that will be pattern on the photoresist only through the UV light, X-ray light, or UV light, or whatever the source you want to use. Okay,
Okay. Okay.
so what will happen? So suppose that I will take this is the my substrate. I will insulate it through the some SiO2 layer or that insulated layer, some metal oxide layer. Like that, there is a
Okay.
silicon. I have put one SiO2 layer.
Yes, sir.
Okay. Then I spin coating photoresist, either positive and negative here.
Okay, sir.
Okay.
Hmm.
Then there is a one shadow mask here. Okay.
Yes, sir.
Suppose this thing I want to transfer. This is a blend. Okay.
Yes, sir.
Then what will happen? I will expose the UV light here. Okay.
Hmm.
what will happen? This will be pattern here. Okay.
Yes, sir.
Now, in case of the positive photoresist, when you have to do etching means you have to remove the unwanted things from your substrate that you not want to things. Okay.
Okay, sir.
Suppose this is I have deposit. This is the suppose this is contact of either gold, aluminum, or silver, or chrome, whatever the material you want to for electrical conductivity. Use this material here for source and drain. Okay. Suppose that I want only these things on my substrate, and I
Okay.
do not want this photoresist. In between that, there is no exposure there. The light will be not exposed. Okay. So in
Okay,
case
sir.
positive photoresist, the etching will remove this area, and this will be remain on your device.
Okay.
Yes, sir.
In case of the negative photoresist, this will be removed. These things. Only this area will be covered. Understand?
Yes, sir.
So as per your requirement, where you want to transfer and what area you want to protect or stay on that sample. So according to that, you choose the photoresist,
Okay, sir.
and according to that, you choose the etching material. Like that, if you remove the silicon oxide, you choose the KOS solution. Okay.
Okay, sir.
For gold, you have to make the gold etchant. For aluminum, you have to make the aluminum etchant. So whatever the
Sir,
material you have on the surface of the silicon substrate and you want to remove, according to you that choose the etchant. Okay.
Yes, sir.
So you have to decide that which material you have to deposit and what is etchant you have to prepare that. The etchant will be available in the market. You can prepare in the lab also through mixing some 3 to 4 solution chemical reaction, and that you can make that. Like that, this photoresist can be removed through the acetone only. Okay.
Yes, sir.
Uh,
sir,
any other?
sir, I have one doubt.
Yes.
Like, we use only buffer hydrofluoric, right, sir, instead of KOH.
Yes, we can use that buffer hydro. That will be also that concentration of either 1% or 10%.
Okay, so we use
That's why
both.
it's called buffer solution.
Oh, okay, so we use both KOH and buffer solution for removing silicon dioxide.
Yes. Why we not use many cases not HF solution because it will be to handling HF is very difficult.
Ah, okay,
And
okay.
it will create a damages, or if the concentration will be more, it will create a damages on the surface of substrate also.
Okay, okay. Yes, sir.
So people are using that but diluted solution. Some people are using 1%, some are 10%. That's either
So,
your requirement. That according to that you can use that.
so we use KOH or buffer hydrofluoric more. Which
What?
one?
You can use whatever available. You can use both. I think the KOH will be. It will take the time to remove KOH.
Ah, okay, okay. Yes,
So it
sir.
will take, like that. If you make the 30% of the KO solution, that KO is a potassium hydroxide. You have to mix that in the ethanol or IPO some solution, and it will
Mm.
take around 1 hour. You have to put that your SiO2, and then it will be removed.
Ah, okay, okay.
So it's depend upon the timing and application. How do you handle that during that fabrication?
Yes, sir. Yes, sir.
Shamlal, anything else?
Yes, sir. Now
You can
doubt
go
is
to my
clear.
previous video, like last week 6. I have explained that photolithography is more that, and week 5 also I have some mention about that. What is the positive, negative, and etchant also that.
Okay, sir. I will.
And if you have an other doubt, you can write to me. I will explain to again that no problem for half an hour that.
Okay, sir.
Anything else?
Sir,
Shamlal,
why?
other,
Yes, sir. Sir, why
uh,
you are using always Si as a substrate?
SI is very low cost, present in the environment in abundant quantity.
Okay, okay.
Like that, SI will be manufacturing through this sandstone, sand.
Yes, yes, sir.
So it will be available in the large amount in the earth. That's why it
Okay.
is very low cost and easy to manufacture that. Even if you see that my first and second video, I have explained that how the silicon vapor in video week 3 or week 4, how the silicon vapor will be identify p-type and by how to be fabricated technology that CGD is quasi method, and that anything that we can now manufacturing 80-inch diameter of the silicon vapor.
Okay, sir.
Okay, so large
Yes.
scale vapor will be available. On the large scale we can integrate many system on that same vapor.
Sir,
Okay, sir.
where do we use glass as a substrate, right? In
Glass
what kind of application?
you can use anywhere in the place of the silicon. You can use the glass, but it will be not maintain at a high temperature. It will
Ah,
sustain till the 500 degrees Celsius only.
okay, okay. But
Okay,
silicon
it will
will
be
resist
correct.
more
It will be
temperature.
not. It is very thick, high. Okay.
Mm-hmm.
So for your that, if you want to prepare or if you want to learn something how to deposit material photoresist, you can use this for glass also, because it is very low cost, around 10 rupees, or slice will become around 10-20 rupees.
Okay. So
So
silicon resists more heat than glass, right?
yeah, silicon is cost around 1200 rupees, or we use the with the SiO2 it is 4000 rupees.
Oh, okay,
Very in
okay.
paper.
Yes, sir, yes, sir.
Okay.
Sir,
Yes,
But
sir.
in
compared
future,
to other substrate like that quartz, sapphire, some are that PT coated SiO2, they are GaN hemp, GaN vapor, they are very costly, around 2 lakh rupees, 3 lakh rupees.
Oh, yes, sir.
That's why we use the silicon.
Yes, sir, yes, sir.
Anything else,
mm,
Sham?
yes, sir, it's fine.
So should we move?
Yeah.
So I think this is for Jabira. I will explain in the last. So can you answer me these questions? Anyone?
Oh,
Really?
yes, sir. Sir, I also have one doubt here regarding microfluidic channel.
Oh yeah, tell me.
So, like they have mentioned that microfluidic channel can also be made in paper. So, is that really possible in paper? Like because
Yes, yes,
fluid is
yes, it is
flowing on
possible.
paper,
It is possible on the paper also.
but since the fluid is flowing, the paper won't get how to
They are
say.
they using the some special. They have coat with some layer that on paper.
Oh, okay, to resist the heat from
Yes,
water.
yes, yes, yes. They use some
Okay.
material to coat on that paper something.
Okay. So
Like
like
they
water
use
resistant.
silicon as a substrate. They use the paper as a substrate.
Okay, okay. So above
Now,
that they will
now
put.
people are working on the flexible devices. People are using the cloth material to fabricate the devices.
Yes, sir. I have watched like MIT students have invented paper circuits, like circuits
Yes,
on
yes.
paper.
Because they are
Mm.
easily to bend, they are easily to
Ah,
use, low cost, and even they are making the devices on that t-shirt and
mm,
shirt materials.
yes, sir. Yes, sir. Okay.
Okay,
Yes, sir.
so you have to just optimize that how to they have you have to coat and everything. Some material will be used that,
Mm,
and then they have to transfer the microfluidic channel through photolithography on that material paper.
yes, sir. Yes, sir.
Okay,
Yes.
so can you attempt these questions? Anyone?
So both option are correct, sir.
Why? Reason?
Because like in the experiment they have mentioned like multi-channel peristaltic pump can flow liquid at different flow rates. Like we can use the settings to modify the flow rate for each channel. And in statement two, the flow rate is in the range of microliter per minute. So that's also correct.
Okay, so what is the application of that?
Like if you see our human body, we have the heart pumping, right?
Yes,
So we want to mimic the same kind of things in the microfluidic channel, like some liquid is moving at a flow rate. We use this kind of peristaltic pumps, like our body, mimicking our internal body structure,
yes,
like
yes.
heart.
So you can flow the control of that blood vessel through that pump,
Hmm.
microfluidic.
Yes, sir.
If your heart will be not working, you can put the microfluidic channel in between vessel and you can operate that.
In our human body.
Yes, yes.
Oh, okay.
So they have just connected a vessel, blood vessel through that microfluidic channel, and then they will be distribute the flow of the blood to the different veins of that human.
So like when they are doing heart transplant, they would use these kind of pumps, sir.
Yes,
Like
yes, yes.
okay, okay.
Okay.
Hmm.
Second, Shamlal, you can attempt also. M. Misra, you can try that. You will be also participant. If you not, it is not that you have to answer that right. That you should try. It is just discussion class.
Yes, sir.
Yes, sir. Yes.
So you should also try that. We have to just healthy discussion will between me and you that.
Yes.
Maybe I am wrong on that place and you are correct. So you can try that to attempt that.
So fourth one is wrong.
I asked the which does not hold. First one is wrong.
No, fourth is wrong.
Fourth one is the wrong. Why?
Uh, It is written vacuum is not compulsory. Vacuum is required now for
Yeah, like
physical vapor deposition.
we should
So,
do some vacuum, like
so
Yeah.
what is its meaning? These three meaning.
so like additive microfabrication is like directly depositing the metals layer by layer.
Okay.
So, but I have also one doubt, like whether E-beam is additive microfabrication or sir. I have one doubt like that.
Yes, it is additive. It is good, strong additive, and quality of the film is very good.
Oh, okay.
Okay.
Yes,
Because
sir.
what will happen in this case? Like that, there is a gun. Like that, there is a tungsten filament.
Mm.
Okay.
Mm.
This is the gun. There is
Yeah.
a source supply. There is electrode gun here. Okay. It is made of the tungsten, and supply is in the kilowatt or megawatt.
Mm.
Okay. What will happen in the e-beam lithography, electron beam lithography? So like that, this is the my sample holder. Okay.
Mm.
Here we put the like silicon, glass substrate, anything here hold, and
Yeah.
there is a one boat is here. There I have put some metal or some oxide material here. Like that I have put a gold here. Okay.
Okay.
In- Okay.
Mm-hmm.
So what will happen that the gun will be that gun electron will be strike on that metal and it will melt that metal. So the strike that positive or ion or negative ion beam.
Oh, yes, sir.
Okay, ions. When will it will strike? There is a vacuum in this chamber. Hole that this chamber will be vacuum around 10 ki power minus 6 or 10 ki power minus 7 pressure millibar.
Sir, yes. What is the difference between the Tor and millibar? Like,
But the same, some people will be using a tor or millibar. It's like one tor equal to 10 ki power 3 bar or like that something.
so we use the both the quantities.
Some people will be represent like that in kg or that in gram. Same thing.
Ah, okay, okay.
Okay.
Yes, sir. Yes, sir.
So it is represented. Some people will be mentioning that or some will in a millibar like that. It is you're just a conversion of that unit.
Okay, okay.
Some
Yes,
people
sir.
will be measure the pressure in the torr, some millibar.
Mm,
Okay. So like
okay.
that pressure is in the negative. 10 ki power minus 6, 10 ki power minus 7. In the vacuum like that in the space. Okay.
Yes, sir.
So what will be happen there? There is a pressure will be low, so it will be evaporate and it will be deposit striking that ions on that this film. Okay, and it will be rotate. So uniformity will be more because uniformly it will be rotate and ions will be strike on that surface of substrate.
Yeah.
Okay, like that this will be rotate here. RPM some RPM will be there and material will be evaporate on that striking on the surface and it will be striking and at what amount of the time or thickness you want, you can control that through that timing.
Okay. Yeah. So
So
are you
suppose
saying
that
the
you want to,
crucible will be rotating?
no, crucible will be fixed. This crucible will be fixed.
Oh, only the substrate will be
Substrate
rotating.
rotator will be rotate
Ah, okay. So,
because
but
because if it will be rotate, then we will, that electron will be not staying. That gun electron will be here and there. That we have to
but yeah, but in the video they have said like they do some XY patterning. So how does it affect the?
X-ray.
No, no, XY sweeping.
That they have to shipping that that this gun position of gun.
The changing the position of the gun is like
That
changing
filament,
the.
they tune the filament in the X and Y direction. Some they rotate the filament.
Okay, so
Not the
both the.
crucible will be hold in the fixed place.
Okay, okay.
It will be generate some circular strip when the gun electron will be generated like that. This is the gold, and then
Mm-hmm.
this will be circularly there will be striking of that. The ring will be formed in that crucible.
So like when the electron hits, there will be some ring kind
Ring
of.
will be formed. Some ring or some elliptical structure is depend upon that gun direction, that electron direction.
Oh, okay. So you just move the filament and not the
Yes, sir. That
this.
that that whatever the movement of that gun, that the weight will be striking. Uh, if you they have shown in the video that maybe that chamber that they have shown that internal chamber.
Yes, sir.
Okay, so I think
Yeah.
like that there is like that. This is the secondary gun will become. There will be one point there. The electron will be that the light will be falls on through that some holes will be there on that
Mm-hmm.
crucible. So you have to that hole you want to that like move that up and down, that you can change the position in X and Y direction.
Ah, okay, okay. Now
So
I
you want to
understand.
focus on the center or some side or some that where you want to evaporate more AU, that you can decide that evaporation rate.
Hmm. Okay, okay. Yes, sir.
Okay, so
Hmm.
so because if it will be in the atmosphere pressure, that evaporation will be not move in the up and side, because the electron will be from low pressure to high pressure to low pressure.
Mm-hmm.
So that's why that staking will be happen. If the pressure will be not there, then evaporation will be not done that case.
Ah,
So
okay.
you have some inert gas you have to use to carry that electrons and nitrogen and argon in case that in the during the deposition process
Okay, okay. Yes, sir.
in the chamber.
Hmm.
Next question. Can you answer that attempt to?
Hmm. Chamber evacuation. Sir, all
All
the
of
which of
all of above, sir.
all the
Correct,
all
sir.
of the above. Yeah.
What is the meaning of that?
Like for sputtering, we need to create the environment like uh, chamber for it. So first one holds true. Second one, the potential difference between the target and substrate is needed, like highly negative potential. And also
Okay.
plasma contains positive, negative, and neutral atom. That also holds true.
The chamber evacuation process is not necessary before sputtering. The high potential difference between target and substrate is not needed to create a plasma. Plasma contain positive. So I think you plasma contain positive, negative, and even natural item. That this statement is hold only that things, not all of the above. Reason is that you need to evacuate the pressure before the sputtering that process. Okay,
Yes, sir.
you create the vacuum. Okay, and you have to remove all the dust particle and atmospheric gases, oxygen from the chambers. So evacuation, so you use the some rotary pump or turbo pump to remove everything that. So
No,
evacuation is needed for that sputtering.
but are you sure whether the plasma contain whether the plasma statement is does not hold true? because I have
High
still doubt.
potential difference between target and substrate is not needed to create a plasma. ठीक है ना? So how will be plasma will be created?
Uh, Plasma, we have the oxygen plasma, right?
Not oxygen plasma is there. Oxygen is just a gases that help to create the plasma. Plasma is
Okay.
created through that RF supply, radio frequency supply or DC supply. If the
Mm.
metal will be there, you have to provide some DC bias voltage to the gun that hold the target. Okay, so this type will be gun will be there, and here is some holder. There you have to mount or hold that target, and here you have to provide us some electron. There will be some magnet will be there in the gun, and it magnet will be generated a radio frequency, that electrical and magnetic field, that will be through the presence of that argon or nitrogen oxygen gas. It will be evacuates from the surface of the target some metals.
Mm. Yes, sir.
Okay,
Mm.
and you have to cool down or some cold water will be needed to cool that, because there is very high field will be generated and it will be heat. So
Mm.
to sink down that heat, you need to supply that cold water to also through the gun.
Yes, sir.
Okay, so a high potential and target difference will be needed to the create plasma. Without that, you cannot create a plasma in normal condition.
Yes, sir.
So plasma content that positive negative ions depend upon the materials, how they can be react and what atom will be evacuated from the target. Either it will be positive or negative depend upon the evacuation of the like that you use that oxygen or chromium target, copper target. Okay, copper oxide, CO. Maybe that you generated CO plus 2 or CO minus 2 atoms will be released from that materials, or normal a neutral atom will be generated through that.
Yeah. Yes, sir.
Okay,
Yes.
understand?
Understand, sir.
Anything?
No, sir.
Ram?
No, no, sir.
Ramlal?
Yes, yes, sir. I understand.
1 minute, please. So, next, can you answer? Shyamlal,
Yes, sir.
can you attempt these questions? Can you try to?
None of the above.
Yes, yes. Yes, Sutan. I'm.
Yeah, yeah, none of the above.
Why?
Because plasma cleaning, like we can use it for surface activation or cleaning the surface through the ionized gases. And
Okay.
second point is like we, as you said, like we use oxygen or some kind of material to create the plasma. So oxygen or argon is also used. So and it is also performed in a vacuum chamber, controlled pressure.
Yes, yes, yes. So why we used that plasma cleaning of the substrate like that? Okay, like that you have to
Yeah.
take in a glass.
Mm.
Okay, for
Yes, sir.
making any device.
Mm-hmm.
Now, if you have to clean the glass, some process will be there, that RCA1, RCA2, that reactive chemical process will be there. like that you have to put that in the acetone or IP, and you have to sonicate through some timing. You heat that material, but what type of some organic material will be remain in that surface of the glass, and if you see through that any microscope or scanning electron microscopy method, you see that some dust will be there on the glass. From your naked eye it see that it is clean, but in the microscope when you have to zoom around 50x or 100x, you see some impurity will be there on that, and it will be not desirable for the any device. It will be damage your quality of the device. Okay, so what will
Yes, sir.
happen, you have to put that that glass slide in the chamber, and you have to make the vacuum of 10 to power minus 2 or 10 to power minus 3 pressures, and then you have to generate some argon or oxygen plasma, and they will be hit on that surface of the glass and extracting some impurity through that material. Okay,
Yes, sir.
and it will
Yes, sir.
remove all the impurity through that surface, and it will be clean.
Mm. Yes, sir.
So some that in the clean room there will be facility of the plasma cleaner.
Mm.
Okay,
Yes, sir.
so it will be last process to clean the vapor.
Ah, okay.
Okay,
And also like,
what
here, what is the why should the return RF frequency should be very low compared to the input frequency?
what plasma frequency?
No, to create the plasma, we use the RF system, right? RF frequencies.
Yes, that will be because we create that plasma will be created through the electromagnetic field will be generated through that only.
Yeah, and they have said the return RF frequency should be low. I don't know why they say it so.
Because we need a very low intensity of ions that. If the
Low.
intensity of the ions will be more, it will be damage that surface of that paper. It will be react with the glass atom also that.
So, yeah. So you're saying the RF frequency creating the
See that.
ions.
See
Mm.
that. Like that one ball is big, one ball is small.
Mm-hmm.
You threw both the ball on any surface.
Okay.
Who will be pressure will be more?
The big ball.
Big ball. And
Mhm.
what you want that it will be suppose that you threw the one small ball on the glass and one big ball on the glass. What
Mhm.
will happen?
The big ball will break the glass.
Break the glass. It means it react with the glass atom also. It will be damage the glass surface. It make the rough surface of the glass. When the high intensity of the atom will be strike on any surface, what will happen?
Oh, it will damage the surface.
But we don't want to damage the surface. We want to just remove the impurity on the data atoms.
Ah, okay.
That's why
So
we need a low frequency atoms. They just strike on that impurity and that remove that impurity with that intensity of that ions.
so if the RF frequency strike the impurities, and if it again gets reflected back, it will get a very high charged ions. It will damage the substrate, right?
Yes, yes. And
Ah,
we completely that we own that vacuum pump or rotary pump. It will be create a low pressure and it will be stuck that item through that plasma. That gas
ah,
will be in the chamber will be that continue flow through. In and out will be continue.
oh yeah, yes
Okay.
sir.
So what will
No.
they ionize that argon or oxygen atoms, and the ionized argon and oxygen atom will be strike on that metals
Oh
surface,
yes sir. Mm, yeah.
and they react with that impurity and they stuck through that surface.
Mm, yes sir.
Okay.
Yes sir. Yeah. Now I understood.
That's
Very
why
well,
we need
sir.
a low frequency only in that case.
Return
Not
frequency should
high
be
frequency.
low. Yeah.
Sir, I have a question.
Yes, yes, Shamla.
Sir, plasma cleaning is a process of removing all the organic matter. What does it
Organic,
mean?
yes, organic means some types of that oil, some food will be contamination, or some that dissolvable easily. That if there will be some metal that will be not react with the argon
Oh,
plasma, then you have to use some agent that.
okay, sir.
Okay,
So
suppose that
plasma
you
only.
suppose that some oils or some water vapor will be there, some moisture will be there on that surface.
Okay.
Okay, so first I use the deionized water and remove, and you flow the some that you blow some in the nitrogen or argon gas. You see that some stickiness will be there on the surface.
Okay.
So that will be removed through that plasma only. That
Okay. Okay.
okay.
Yes, sir.
Uh, you can see that if you some bacteria will be there, man. Suppose that
Yeah.
how kill you that bacteria, Shamlal?
Yeah.
Yes, sir. Through antibiotic. Uh,
Antibiotic we have to take antibiotic, but on the
yeah.
or like that some suppose that in your lab,
Yeah.
okay, how you
Hmm.
sterilization the instrument,
How to? I don't understand.
sterilize the instrument. Suppose that in the you are in the hospital. Have you
Yeah.
visited hospital?
Yes, sir.
How they sterilize the instrument that catchy and that tweezer, syringe, and then how they will sterilize that equipment they use through the surgery and on the patient,
They are using alcoholic type chemical.
alcoholic or anything,
Sir, is that UV light?
UV light.
Mm.
So what will do UV light?
I'm not
You
sure.
will have to kill the bacteria's.
Kill the bacteria. Bacteria is the organic compound.
Yes, sir.
Hmm.
So UV light will be created through the plasma also. That
Okay.
Oh,
people that people are working to create the lighting through the plasma process. Okay,
why
Yes.
can't we just use UV light instead of the plasma cleaning?
see that plasma is just a process. If you use the UV light, it will be maybe that damage that UV light also will be not remove that sufficient material.
Okay, okay.
If you do the sterilization only, you want to kill the bacteria. Can UV light remove the oil from that substrate?
Oh, no, no.
Then
Yes, sir, yes, sir.
and
I
now
just
the
thought.
people are that UV light based on the mercury material. Okay, people are the feel the some mercury material and it will be generated some UV light that is wavelength that. Okay, now people
Hmm.
what we do that they use the plasma. They fill the light with the krypton or xenon gases and they generated UV light through the plasma process.
Yes, sir. But UV light is also bad for us now.
UV light also bad for us, but plasma will be done in the vacuum. It will be not released in the atmosphere.
Yeah,
Okay, sir.
yes,
Okay.
sir, yes, sir.
But sir, in clean room, we are using UV light or any other light? Uh,
In the clean room, for what case?
yes, for clean room for our instrument or when we are
If
going to
you
clean
do
room.
the sterilization, then you can use the UV light. Some in case of that bacteria or that. 1 minute, maybe I will disconnect it. Give me 1 minute. Sorry for sir. Move.
Yes,
Yes, sir.
Sorry for I have one call. That's
Okay.
next we have to move the thin film deposition technique. So thin film can be deposited by the two process. One is the chemical vapor deposition, and another is the physical vapor deposition process. So in the chemical, we use the some CVD method that is called that atmospheric pressure, low pressure plasma enhanced, and high density plasma. Okay. So maybe that this will be on week 9 or week 8. This is the some chemical that CVD, that furnace will be there. Okay.
Hmm.
So while I like that, this will be the furnace. This is a tube, that glass or quartz tube they have used, and there is some heater will be there heating. This is the heater. They on the crucible they have to put some material like that. There is a aluminium crucible, some material they have to put there we want to deposit, and there and above they will use the substrate, glass, silica, and what. So what will happen? They have increased the temperature of the heater, and this is the they have the flow the some gas here. Okay, some nitrogen, argon, or oxygen or hydrogen, whatever the requirement to react that material that. Okay, and when this is heating, the atmosphere pressure means that CVD will remain in the atmospheric pressure, like that in the 700 bar pressure, atmosphere bar pressure. Okay, in the LPCVD we have to create the vacuum in that 10 to power minus 2 or 10 to power minus 1 pressure, and rho T will be continue will be flow. In the plasma enhance, we use some material that will be create the plasma inside that. Here, we have not used the heater. In the high density plasma means density of that means that vacuum of very low. It is go to 10 to power minus 3 or 10 to power minus 5 pressure.
Yes,
So
sir.
you have to in the sensor you have to in the lecture 7 or 8 you have to go through that. They use the physical vapor deposition, E beam, electron beam evaporation system, or RF splitting or DC splitting system. So we have to focus on these more things. So what is the difference between the chemical and physical deposition? In the chemical vapor deposition, reactant gases introduced in the chamber of the gases on the vapor surface result in the layer deposition. So reactant gases like that argon, nitrogen, hydrogen, we use the gases to deposit some materials. Low pressure technique primarily used for this material, silicon Si2, poly, silicon nitride film in the semiconductor for industry. PVD or vacuum means PVD means physical. We have to use some vacuum. Like that, I have to ask that we need a vacuum in the E-beam evaporation system. That is the wrong statement. We need a vacuum. Without vacuum, it will be not deposit any material, evaporate. Used to produce the atoms which condense on that paper. Condense means they have to stick on that paper.
Yes, sir.
Method used to produce flux including evaporation, heating, whatever that we can use the flux that tungsten will be create a electromagnetic flux, or some plasma will be there, or we have to heat that material. Yes, Sutar, anything?
Yeah, yeah. No, sir. No, sir. I didn't, sir.
Okay. In the sputter deposition, bombardment of the material by energetic ion means we use the RF to bombardment of the atom on the surface of that substrate. Target. We create the ions of that argon or oxygen, whatever that gases we use for the RF plasma created. These ions will be striking on the target material, and it will bombard it on the surface, and they release the ions. Okay, and then ions will be there. That atoms will be stick on the surface of the film. Mostly used
Yes.
for the metal and alloy deposition system. If you may use to deposit some metal like gold, silver, copper, aluminium, nickel, chrome, whatever the metal you want to deposit, you use the physical vapor deposition method. Or some alloy, mix of some that magnesium oxide, zinc oxide, okay, gallium oxide, molybdenum oxide, tungsten oxide, that you have to deposit through that in vapor deposition.
Yes, sir.
You can deposit silicon oxide or silicon nitride also through this process also.
Hmm.
Okay, but this is
Yes.
very costly. It will come with the cost,
PVD
but
costly as well.
it is very low cost.
Ah, okay, okay.
So this is the physical deposition paper technique. You see this is very big machine. Okay,
Yes, sir.
so this is the supply, RF supply or DC supply.
Hmm.
This ray contains the supply. Okay,
Yes, sir.
and this is the gun. These are the gun where you have to hold your target.
Hmm.
And this is the chamber. There is a one motor and everything. And this will be rotate, and this is the inside chamber. Everything that. So oldest of the thin film deposition technique, hundreds years or more. It is we use hundreds years before this technique to deposit because that quality of the film is very good, and we need the quality of the devices. Okay.
using PVD.
Yes, yes. And it will be uniform deposit. Equal layer,
But
the thickness will be uniform on over the large surface also. If you use a 2-inch wafer, it will be deposit. Or you check the all the corner thickness will be uniform. In
which
case
one
of
is
the
faster?
yes, and in case of the CVD or LPCVD, the uniformity will be less.
Yes, sir.
That is the disadvantage.
Sir, but which kind of deposition is faster? Like which one is more speed?
Costly will be that PCVD, that
Oh,
PVD.
oh, so CVD is slow and not uniformity.
Uniformity will be very less in that case.
Okay, okay.
Okay.
Yes, sir.
Only physical processes are used to deposit thin film on the substrate, like that individual atom or molecule of the material to be deposited are produced by the evaporation. Okay, so evaporation means it will be evaporate, not melt. The phase between sublimation and melting, it will be in the gas form. Evaporation means fume will
Yes,
be
sir.
generated, some fume type.
Mm.
Okay, so what will be
Yes,
first? The
sir.
metal will be sublimate and then some evaporation will be start.
Mm. Yes, sir.
Okay. So
Mm.
how metal will be sublimate? Because ions will be striking or heating, it will be generate the heat. It will be condense the heat, and it will be start the sublimation.
Mm. Yes,
It
sir.
will be in a melt form, and then
Mm.
the gas will be come on the surface, and gas will be take that evaporation on that the flow of the turbulence that gas will be flow that it will be contain some evaporation atom and it will be deposit on a material that above that there, or you have to put whatever that position that required.
Oh, yes, sir.
So ions atom travel through the vacuum and to and condense on. So there is vacuum will be 10 to the power minus 6 or 10 to the power minus 7, and that condense on a vapor low pressure implies very few gases phase collision. Okay, means low very few gases collision of the atom will be very low in that case. So if the collision will be atom, it will be again break the atoms,
The
and it will
uniformity
change the
will.
phase of the atoms also, change the
Uh,
property of the atom.
oh, yes, sir. Yes, sir. Collisions will be less.
Very few chemical reactions means unwanted chemical reaction will be not happen.
Mm.
Means impurity will be low in that case.
Mm.
So
Yes,
that's
sir.
why the good quality of the film you get.
Yes, sir.
Reactive splitting, species splitting in the reactive gas like N2 environment, so there will be very less oxygen, atmospheric oxygen will be less. Rapid process, मतलब कि very fast process, thus thickness, uniformity, step coverage and sorting due to the topography can be issue. Okay? Any questions from this slide?
Like, what is the step coverage mean?
Means if you make the some step here to measure the thickness, like that, this is the paper. I
Okay.
make the some step here like that. Okay,
Mm-hmm. Okay.
and I will cover some material through here, and I will want to deposit here only without this step. Okay,
Okay.
what will be
Mm-hmm.
happen that some material step will be covered through the metal also that, and you cannot get a proper step that where is the substrate and where is the whatever the thickness of the metal.
So you are saying like using PVD, the step will also be coated with metal.
Yes, sometimes. So it will be difficult that you make the proper step.
Okay, okay.
Okay,
Mm. And what do you mean by topography?
means morphology. What is the structure of that material? Topography. How much? How it will be deposited? Like some
Okay.
cases there will be nano rods type structure. Some is the nano sheet type of the metals. Some is the flower
Oh,
like structure will be there.
oh, the deposited metal will be like these kind of structures.
Yes, yes. Topography means how to see the top surface of the material.
Okay, okay. Yes, sir.
Okay.
Mm.
Sir,
Anything
I have
else?
a question. I have a
Yes, yes.
question. Sir, it is a rapid process, no?
Yeah, fast process.
Fast process than CVD.
Yes, yes. Rapid means atoms will be stacking very fast because continuous
Okay,
plasma will be there, or
okay,
E-beam will be continually stacking on that material. Uniformity,
okay. The uniformity is fine for this process.
like that. If you in the vacuum chambers, okay,
Yeah.
the
Hmm.
atom will be continually evacuated from the target.
Okay,
But in case of the CVD, there is a random stacking of the atom and movement of the atom.
okay.
So it will take times.
Okay. On
Mm.
that sense, the rapid process.
Yes.
Okay.
Ah, yes, sir.
Where is Zabira? It will not join yet. It is
Sir, I also don't know like whether she had some kind of problems. I just messaged she didn't see the message.
any medical issue?
No, not like like probably there might be some works in the house probably for her.
Okay, no problem. So this is the evaporation system. See that schematic of that. This is see this is a substrate holder. Vapor will be hold here. Okay, and this is the crucible vacuum. This is a vacuum system. This is the you have to crucible, and there is a heater or E beam will be stuck here. Okay, either you give the heat, you make the you increase the temperature of here this holder, it will be melt and this will be evaporation.
Yes, sir.
Okay, see the
Mm.
source material is heated in a vacuum. Thank you for money store example AU plates. Suppose that this is the gold. There you have to make that gold. Resistive heating with tungsten filament means the change of the resistance of the that with the heating the resistance will be change of the material.
Mm. Yes, sir.
So you heat the tungsten filament and you give the current on that tungsten filament on positive and negative side and increase and it will be heating. Like that you have to make the temperature of 850 degrees Celsius, 1000 degrees Celsius, 2000 degrees Celsius as per the melting point or the boiling point of that materials. Every materials have the fixed boiling point and melting point.
Yes, sir.
Okay, like
Mm.
that gold will be evaporate around at 2000 degrees Celsius or 3000 degrees Celsius. It requires very high temperature to melt.
Oh,
So
yes.
we cannot heat that metal on the 203 degree Celsius. Okay, so what will we have?
Yes.
We use the E-beam in that case.
Mm. Yes,
We
sir. Yes, sir.
we striking through the electron.
Mm-hmm.
Okay,
Yeah. Why can't we use just a E-beam instead of this thermal evaporation? Like,
thermal evaporation. Can you go the temperature of the 2000 degree any substance material and it will cool down? You need a
sir, no.
reactor.
Yeah, no, I just say like when using that thermal evaporation when the material to be heated has very high temperature, at the time we use E-beam, right?
Yes,
But why can't we just use all kind of metals in a E-beam? Like whether is it possible?
we use the any metals. Even we can
Okay.
evaporate the aluminum, gold, silver, anything can be evaporated through the E-beam.
Okay. So why
But
are we
cost is
still
very high in that case.
using that thermal evaporation? Like
But cost is
wh-
very low. And it is easily, cost of the E-beam is around 80 lakh rupees and 1 crore.
so the cost wise,
And
okay.
thermal will be 30 lakh rupees and 40 lakh rupees.
Oh, wow. Okay,
Okay?
okay. Yes, sir. Yes,
Because
sir.
you use the gun. In the thermal, you know
Ah,
that in a gun. You just
mm,
hitting the filament to the current.
yeah. Mm-hmm.
Okay? And
Yes,
gun
sir.
will
Yes,
make
sir.
up the tungsten.
Mm-hmm. Yeah.
Okay?
Yes, sir. Yes, sir.
Yes, sir.
That's why.
Oh, yeah.
And
Now I
thermal
understand.
evaporation, you need a turbo pump 10 to the minus 6. You can go the turbo. You need a very high vacuum pump, argon, and that everything. The system is very sophisticated.
Yes, sir.
That's why. So
Okay.
people are using that, and it will like that in the E-beam. That additive of the film is very good, but in the thermal it is very less.
but the cost of e-beam is very high.
That's that's why cost, and it is not easily available to everyone.
Yeah, yeah,
That's
yeah,
why. But
yeah.
in the industry, people use the e-beam only.
Mm, yeah.
Okay.
Yes, sir.
Like
Yes.
Intel and AFD, that they have to fabricated a devices like that processor, they use the e-beam only.
Mm,
Yes, sir.
yes, sir.
That's
Mm,
so this is the that vapor holder and angle between that substrate and that how that atoms will be striking on that sample holder. That's if you hold like that at some angle, and then that point source will be move on that with some angle, that transport of that condense of that atoms on the surface of that. Okay. So
yes, sir.
topology you can change through the holding of that substrate also, that metals.
Ah,
So that topology or morphology of the devices you can change through the angle or some holding of the substrate holder. You can change the topology also, that metals.
mm, yes,
Okay.
sir.
So this is the need how to be calculate that striking on the area that atoms, that this is the formula, that flux and striking between relationship between.
Ah,
So how much the rate, how much the distance. So we have to optimize all the things through these things. How
so
much
we
the
need
time
to.
deposition time we require, how much the RF supply we have to given, that 10 watt, 100 watt. Okay.
Mm,
What is the distance between that target and substrate holder? We have to keep around that recommended that people 7 centimeter. Some case we have to put the 5 centimeter also, that.
mm, yeah,
So these are the only the mathematics. Maybe it is very deep. I have to include that deep things in class. I have not. I think that they have explained that things.
yeah. They did not mention these kind of things in the class.
We have just explained the basic of that deposition process.
Mm, yeah.
So this is the graph, that deposition rate of that film as a function of the position of the substrate. Okay. So this is the how do you change that position of the substrate, and this is the deposition rate. Okay. So theta
Yes.
L and theta KH is the configuration of both point and substrate source. One is that theta, this is the for that point source, that material will be rotated, and this angle theta K or theta H will be that for that position of that substrate. About how to, at what angle you have to put that substrate. Some people are put the horizontally, some make the angle to hold that substrate.
Mm.
This is the holder. So that sample holder they have put.
Ah, so here we have the angle.
Yes, yes. So this is the temperature dependence. So we can put the temperature to the substrate also in that PVD. We have the filament there, and when like that your sample will hold, there is a filament. We can heat that substrate also. That we can put the temperature to substrate also, and it
Mm.
will be easily stacking of the material. When it will be heat, it will be easy to stacking a more number of the atoms on the surface. It will provide a more site to condense the atoms on the surface of the substrate when we heating the substrate. Okay, so your
Yes.
deposition rate will be also increased with the heating.
Like when we increase the heat, like the,
Yes, when
the
we give the temperature to the substrate, silicon or
mm,
glass substrate we use, so we put the temperature like that for according to our requirement.
so the temperature, the rate of deposition increases with
Yeah,
temperature.
it will change the phase also, that like that some metals are the insulator. Suppose if you
Mm-hmm.
deposit on the room temperatures, so it will be
Okay.
remain in the insulator. But if you give the like that 500 600 degree temperature, it will be changed in the crystalline form also.
Uh, oh, so the metal will, the deposition metal will be become insulator or conductor
You
based
can
on
change
that.
you can change the semiconductor behavior or crystallinity of that material also. That with the
Oh,
temperature.
ah, yes, sir.
Again, some metal will be remain in the monoclinic. You can change in the trigonic shape. Okay.
Yeah,
Okay.
but they require high pressure, right? Like,
Pressure will be in the 10 to power minus 6 or 10 to power minus. Pressure will be not required. Temperature will be dependent.
oh, only the temperature.
Okay,
Mm.
like that gallium oxide, the Ga2 3 will be remain in the amorphous case in the room temperature, but it
Mm-hmm.
will be changed in their beta phase or alpha phase or gamma. There will be phase type there. It will change
Mm.
at around 800 and 900 degrees Celsius. Means it will be converted in the semiconductor behavior in the case of the 800 degrees Celsius.
Oh,
So
yes, sir.
if you set your substrate temperature of 800 900 degrees Celsius, it will be automatically converted into the beta phase.
Mm-hmm.
Otherwise, you have to do the handling in the furnace at the temperature of 800 degrees Celsius, and then you have to convert that beta phase. So
Oh,
it will be
yes.
two-step process. But
Oh,
some material will be converted in the 400 degrees Celsius, 500, 100 degrees Celsius.
ah,
It depends upon the material property,
yes, sir.
thermal property of the materials.
Hmm.
Okay.
Yes, sir. Yes, sir.
So this is the advantage and disadvantage of evaporation. No radiation or ion damage. Okay. This is the advantage of that evaporation because we have not used any radiation. We just use the ion beam.
Yeah.
Pure film deposition in the vacuum means quality purity, means no impurity. Metal with low vapor pressure such as W are difficult to deposit. Means that they have require very low pressures. W means tungsten.
Oh,
Okay.
okay. Yeah.
In alloy and compound composition cannot be controlled. Means you cannot control that alloy and compound. If you mix that alloy and compound, and if you deposit a parallel, you cannot control the deposition rate. Means if you want to like that, if you want to deposit aluminium and copper parallelly, okay, and if you want that my aluminium should be 80% and copper would be in the 20%, you can control in that case.
Okay.
Okay.
So we can't control the alloy deposition rating.
Yeah, in the case of the
So
evaporation,
so at the time, what we prefer for alloys?
you do the separately. First, you
No.
deposit the copper, and then you have to deposit the aluminum for some particular time. But
Okay.
parallelly, it's not possible. Alloy compound will be not generated in that case.
So you don't directly deposit the alloys. You just
Yeah, in that
deposit
case,
by
in the
separately.
equation, sir, maybe that aluminum will be more evaporate than copper.
Mm-hmm. Yeah.
So aluminum rate will be more.
Oh. Those
Okay,
sputtering or E-beam, they can't also do alloys.
sputtering will be maybe do that, but in the E-beam it will be not difficult.
E-beam, it will be difficult, sir.
Yes,
E-beam.
yes.
Okay.
Okay.
Hmm.
No in situ cleaning method as in the sputting. In situ means uh, parallel you cannot clean the vapor in case of the sputting.
Hmm.
Okay.
Okay.
So poor step coverage. This is the step coverage we have seen that. We have the deposition space have a stacking coefficient and that. If it is a one that formats like that or it is less than one, see that. This is the curve will be formed on that. Poor stacking coefficient.
Okay. Okay.
Okay.
Yes, sir.
So this is the step coverage and stacking coefficient rate. This is the stacking coefficient rate formula. So F fractal of F incident, F reacted means how atom will be reacted or what about the rate of the incident on that atoms. You can calculate through that how much the stacking coefficient of the atoms on molecule.
Hmm.
Okay.
Yeah.
So second is the sputtering. That how sputtering will be deposition. See that this is the schematic diagram of the sputtering. You read 1 minute for that. Sham, have you visited your clean room facility?
Yes,
No,
sir, I have
sir.
visited.
Yeah.
Oh, okay, okay. I start.
I have visited, sir.
Have you visited?
Yeah, yes, sir.
So have you seen that how much there will be deposition, characterization?
I just seen the machines, not seeing the process, how they are depositing or
Which
they are
machine you have in
evaporating.
the clean room?
Uh, Patterning machines, I forget because I have visited there
Like that
6 months
in the
ago.
in below behind me one machine will be there. Have you seen that machine?
Can you see the machine?
In
Which
behind
one,
my
sir?
image there.
It's not clear, so I can't say.
This is not clean. This
This one.
What
is
machine
it
is that?
few mode you have to seen that?
Yes, sir.
Few mode.
Shoe mode.
In chemistry lab
Fume?
if you visited or chemical lab.
Yeah, you mean fume hood?
Yeah, few mode.
No, sir. I have no idea about field mode because I have not visited any chemistry. So
In chemistry you not in a BTech lab you have not visited chemistry lab basic.
yeah, I have visited, but maybe I forget it.
Okay, okay. Maybe if you have chances, you can aware about that. If your friend will be working on that in clean room, someone will do PhD or project stuff.
Yeah.
So you can ask that how the sense they have fabricated, what is the role of the fume hood, and there will maybe that photolithography or some sputtering will be there, E-beam will be there, EBL will be there, FSM, SAM.
Yes, sir. Yes, they told me all the machines. This is the process of machines.
Maybe it will newly constructed clean room in your IIT. Just recently it will be operational.
Yes, sir. In IITG, this is newly
Yes, yes.
constructed.
So I have seen that there is a lot of facility will be there in that in your.
Yes, sir.
Even we are not the clean room in IIT Jodhpur. We are now start to fabricate that, start to manufacture the building that clean room facility.
Okay.
But in your IIT it may operational that so. So in a sputtering like that, this is the argon. There is some argon. So bombardment in the argon plasma glow discharge. So this is the vapor, and this is the electrode or cathode that make that positive and high voltage between the electrode. Okay, and we make the ground, and this is the sputtering gas inlet that argon, and this is the vacuum pump will be there, and this is the heater that heat the substrate. This is the substrate vapor will be there. Okay,
Yeah.
Yes,
so
sir.
so the metal will be at negative DC, and we have to give the ground and negative DC. So they use the DC supply, and this is the AU. They use the gold to deposit through the sputtering. So we supply the negative bias of the DC supply. So they use not the RF supply, they use the DC. In case of the metal, we use the DC supply. So we provide us some current like the 10 ampere, 20 ampere, 30 ampere through that, and then the argon will be there. It will be create a plasma in case of the DC, the negative electron. Okay. So
Yes, sir.
argon has the positive, and when we have to negative, it will be generated some plasma, some yellow light or like that. Purple light color will be generated plasma.
Hmm.
Pink
Yes,
light
sir.
is.
Oxygen plasma also pink color.
Yes, yes. Okay. It is depend upon the gas, whatever the gas you use for the created environment of the plasma for gases. Argon, nitrogen, or oxygen, or helium you
Mhm.
can use.
Yeah.
SF6 can you be used.
Hmm.
H2S can be used. Carbon or CO2 we use, but they will be very harmful. That will be react with the chamber also, and it will be generated impurity. They are not the inert gases. So many 99% time we use that inert gases for to create the plasma.
Okay.
Okay.
Yeah.
So this is the DC splitting system. So it is similar to physical evaporation CVD system. Plasma is created by applying voltage across the two electrodes. Plasma contain neutral argon atom and equal number of the ions and electron and is connecting medium. No free radicals. Argon does not form any free radicals. Means free atom or any atoms will be created through the argon. It will
Mm.
remain in the natural form only.
Okay.
It will
Yeah.
just argon just will be ionized in the plasma, and ionized argon atom will be striking on that surface.
Mm. Yeah.
Okay, so it will be not damage that target also through the free radicals or any high energy generated atoms. So your target will be in the shape. Like gold target cost will be around very high. It is around 8 to 10 lakh rupees. So any impurity or anything will be happen, it will break your goal target.
Yes, sir.
It
Okay.
will come on the 1 inch or 2 inch diameter, and around 70 to 80 gram gold will be used to make that target.
Mm. Yes, sir.
Circular or rectangle. Yes.
Yes, sir.
So
Understood.
negative bias top electrode is the material to be deposit. Means top. This is negative. Aluminium, for example, like that aluminum, gold, chrome, we can use that. Vapor sheet on the bottom electrode, anode, that will we have to ground. Argon ion accelerated to the top negative electrode and dislodged or sputtered out the target atom. Means they have to locate it on that. They have to pull out that target atom, gold, and that atom to be pulled out through that through the argon atoms. The atom through the plasma and condense on that paper. This will be deposit on that paper here. Target is a conductive material. In that case, yeah, that is the target material. RF or AC method for that electric. We use either RF or DC. Whatever that requirement. For metal, we use only the DC. For metal oxide or other materials, of like that silicon or silicon SiO2 or nickel oxide, chromium oxide, we use that RF.
Mm. Yes, sir.
So this is that how that mechanism will be hold that. This is the vapor surface. This is the negative that from that aluminum target, and this oxygen, that how the atom will be striking here. See that this is the clean. This is this type of the material. The thickness will be deposit. The stacking. Okay.
Yes, sir.
So spectral yield for argon atom does not vary much for different material. Defined as the number of ejected atom from the target per incident ion is the range 0.13. So it will be same for all the materials like that aluminum, chrome, gold, silver, whatever the material you want. It will be range in the 0.123. It will be not change. Depend upon the incident energy and the angle of the incident. So whatever the thickness will be spectral, it will depend upon the incident energy, how much the energy of the argon plasma will be contained. So we like that if you given the 100 watt or 120 watt or 150 watt, according to that energy will be changed, and that will be depend upon that RF energy or DC current. Spectral angle peak should be at 70 degree. So it will be we have to angle between that target gun and that substrate, we have put the angle of around 70 degree. Some people will put on 45 degree also. So depend upon our application, we change that angle also. Multiple target can be accommodated to the gate film on the other example. So we can use the multiple target here. Some sputtering will become with the 4 target 4 gun. Some will become the 2 gun 3 gun. As per our application, we can give the specification to the manufacturer that I need a 4 gun sputting. He will provide a 4 gun with the sputting. So we need a 2 RF or 3 RF plasma. We can take that supply of the RF or DC, and we can parallelly deposit through the 3 gun also, 3 material parallelly to the sputting.
Yes, sir.
Okay.
Yeah.
So this is the step coverage in the splitting. Because of the higher pressure in the splitting system, atom experience more gas phase collision as condensed to evaporation. Means pressure will be high, so atom will be striking in between also that. In case of the electron evaporation, it will be very less collision, but in that case, very high collision will be there. So average number of the collision is based on the mean free path lambda for a particular gas. How much the path will be that free take the path, that depends. So lambda equal to kT upon 2 pi d square p, where k is the Boltzmann's constant and t is the temperatures and d is the collision diameter of the molecules. So it will be upon equal to 4 into 10 k or 0.4 nm for most molecular interest. P is the pressure, that internal pressure, how much the pressure will be in the chamber. So
Mm.
just example, they have the five millitorr. You can take the 3 millitorr, you 2 millitorr or 6 millitorr. It depend upon your depositional pressure.
Oh, yes,
Okay.
sir.
So this give a mean free part to of the 1 centimeter, which almost the physical length of the deposition parameter. So according to take the collision of the atoms, you can calculate through this formula.
Mm.
Another is the composite target splitting means composite means two or three material will be mixed in that target. Okay.
Mhm.
So sputter yield for different material is similar to each other than vapor pressure in the evaporation. It makes sputter deposition from composite targets. Similarly, stoichiometry can be maintained. Also, sputtering occurs from the top layer of the target. Little mixing from the lower layer take place. So you can mixing two to three materials and you can sputter parallelly also that. Okay,
Oh,
and
yes, sir.
whatever the you upper layer should be thickness will be should less because the lower atom will be because it will be striking the atom through the top surface only.
Mm-hmm.
Hello.
Yes, sir.
Sir, yes, sir.
So, as per your composite material requirement, you have to choose the thickness of that whatever the upper and top layer thickness. So, top layer thickness should be less, so it will be striking bottom layers atom also that with the higher energy. Some bottom layer atom should be also evaporate from the target also. Then it will be composite will be deposit on that substrate. Otherwise, it will difficult to pull out that bottom layer atom parallelly with that RF plasma surface. So another is the reactive sputter deposition. Here a reactive gas is introduced in addition to argon plasma. Okay, compound is formed by this reactive gases. Like that, you want to make the oxide surface. Suppose you use the copper target and you want to deposit the copper oxide.
Okay.
Okay,
Mm-hmm.
you use the copper target. Okay, and
Yes, sir.
what your desired material thin layer you suppose that you want to deposit CuO or CuO2. Okay,
Okay.
but you have the only copper, you have no the oxide source here.
Yeah.
So what will you use? You use the oxygen as a gas, oxygen gas.
Okay. So,
So it will
instead
be
of
yes,
instead of argon, we use oxygen. Is that
yeah.
right?
Argon should be used as a because argon have the inert gases and it have the more number of the bombarded. Oxygen will use as a oxide.
Okay.
Okay.
Suppose that you that mass flow control will be there. Suppose you flow that one SCCM of the argon and two SCCM of the oxygen. You mix both the
Okay.
gases in the chamber.
Both the gases won't experience the collision or any, they don't.
Argon will be bombard the atom from that target, and
Okay.
oxygen will be collision with that copper oxide atoms, and it will form the CO2 or CO.
Ah, okay, okay.
Okay, they
Hmm.
will be mixed and collide. They will be chemically react in between that in the plasma, and atom will be
Mhm.
formed that CO2 and CO.
Okay.
So that's why the reactive gases they will be react. They will be
Ah,
chemically react.
okay, okay.
Chemical bond will be formed.
Yeah.
So see that in case of the Ti2, OT react on the target film to form the oxide and then sputter on the vapor.
First, the oxide will be react with the target.
Yes, yes.
Okay, okay.
This is the RF splitting system. Okay. In case of the DC, we use the RF. So this is the RF generator. We have the network matching network. We match the frequency of that RF. Okay. So we use the matching network means feedback layer. Whatever the RF supply we have to give on, and we use the one feedback layer. In the op-amp, you see that feedback layer. If you go to the subject of the control and system, we use the one
Yeah, we
feedback
have, yeah, negative feedback, positive
or
feedback.
positive feedback. So
Hmm.
we have to compare with that supply that whatever the source supply and whatever the output supply.
Okay.
So we have to use the matching network that match the frequency. Whatever the input frequency and whatever the output frequency, it should be matched.
Okay, okay.
Okay, it will be
Yeah,
not reflected. We do not want a reflected magnetic field
yeah,
will not stay back.
yeah. If it's reflected,
There will
the
be a matching network.
mm,
Okay,
yeah,
Yes, sir.
and same things will be that in the DC supply we use that electrode, and this is the process to the RF plasma. Through the plasma, ions will be bombarded on the target. There will be DC electron will be bombarded. In case of the DC supply, electron will be bombarded. DC negative electron.
yeah.
Okay.
Yes, sir.
So what if DC sputter is not suitable for insulator deposit? Insulator means they are not conductive. So metal is the conductive,
Yeah.
Yes, sir.
but oxide will be not conductive.
Not conduct.
So
Mm.
SiO2 is not conductive.
Yes, sir.
So that case we use RF. So positive charge could accumulate on the insulated target, which was cathode. It would be decrease the negative potential required to sustain plasma, shutting it down to 1 to 10 power minus second. So high frequency 10 power minus 50 megahertz instant use RF. So this is the source supply that RF supply, that frequency of the RF should be 13.5 megahertz. Okay,
Yes,
that
sir.
frequency of that RF, but power we can change. Frequency will be remain the same, but power of that RF should be we can change. 10 watt, 20 watt, 30 watt, 100 watt, 200 watt as per our requirement. So power
Mm.
means intensity of that atoms will be changed.
What
Okay.
happens if the intensity of the atom is
If
changed?
we have to given the high intensity, it will be striking more.
Ah, okay,
More
okay,
number of
okay.
the atoms will be moved.
Ah, okay, yeah.
In
Yes,
case
sir.
of the 10 watt, and if you can compare the 100 volt,
Mm-hmm. Yeah.
okay.
Yes, sir. Yes, sir.
But frequency will be what will do. Frequency will be take the movement of the path only.
Okay, okay.
How much the atom will be movement. Frequency will be check the speed of only that.
Mm.
Okay. Because frequency anyway is proportional to time.
Yes.
Yes, sir.
तो मीन फ्री पाथ में आपको कितना मतलब कि एनर्जी आपके एटम्स मूव हो रहे हैं कितनी स्पीड के साथ, वो डिसाइड करती है फ्रीक्वेंसी. तो इसलिए हमें क्या करना
Ah,
चाहिए, कम कम टाइमिंग में हमें मूव करना है, एटम ज़्यादा मूव हो. मान लो कि हमें
ah,
High
10 सेकंड के
frequency.
अंदर, 20 सेकंड के अंदर या 1 घंटे के अंदर हमें मेरे को 300 या 500 नैनोमीटर की लेयर चाहिए.
yeah.
ठीक है ना. अगर मुझे
Then
ज़्यादा
we,
टाइम में चलाना पड़ेगा तो मशीन को ज़्यादा कॉस्ट पड़ेगी, क्योंकि 5 घंटे के बाद मुझे एक डिपोजिशन हो रहा है, टाइम कंज्यूम हो रहा है, पावर कंज्यूम हो
ah,
रहा है, और इंसान मतलब कि इंसान का पैसा खर्च हो, क्योंकि एक आदमी लगाना पड़ता है मुझे पूरा. लेकिन
ah.
वही काम मुझे आधे घंटे में हो रहा है तो मुझे कॉस्टली कम पड़ रहा है.
Yes, sir.
Yes, sir.
गैस ज़्यादा लीक, उस केस में गैस ज़्यादा चलेगी, 3-4 घंटे में मेरा एक सिलेंडर खाली हो जाएगा.
इसीलिए सर हाई फ्रीक्वेंसी की बात आती है जब वो
इसलिए क्योंकि कम
स्पटरिंग की.
टाइमिंग में मुझे, मान लो मुझे 10 मिनट के अंदर ही 200 नैनोमीटर मिल जाए तो मैं 1 घंटा क्यों लगाऊं.
यस सर.
ठीक है ना.
Sir, bus 13.56 or whether higher frequency than 13 also available?
Now they are optimized at 13.56. All the instrument will come in the 13.56. In
So
the
it is
industry,
like,
they are use the high frequency, but for the research purpose or that for some small scale, they use that frequency only. Even that
so
RF plasma, that plasma chamber has also same frequency, 13.56.
okay, okay. Like standard
Yes.
frequency.
So this is the frequency is high enough to maintain plasma discharge in the chamber, higher than the RC time constant of the time. See that of the system. Okay. So frequency should be greater than that RC time constant of the system. Resistance capacitance of the system and device we have to calculate, and that frequency should be greater than that only. Then it will be more move, that fast will be there.
Mm.
Okay.
Yes sir.
Yes, sir.
So this is the magnet splitting. You see that diagram, that how atoms will be that. So see that. This is the magnetic area. There will be magnetic, and this is the target. This is the target. This yellow will be red, and this is the target. Okay. And this is the high and density plasma will be striking this arrow. You can see that, and this will be generated, and it will be move on that anode.
Yeah.
So this is the whole process will be happen in the sputtering system chamber will be closed chamber at high vacuum. So now that we have to move that RF plasma system, how that RF plasma will be remove that organic contamination. Why do we care? Remove organic impurity and contamination from the surface. See that this is the water droplets. You can see it will be on surface. Shamlal, you have to ask me question that organic and inorganic that. This
Yes,
is
sir.
the glass substrate. Okay. It
Yeah.
may be the oil droplet or any material droplet, organic materials. Or
Yeah.
acetone, ethanol, methanol that we use the cleaning process. Some contamination will be remaining after we have to rinse in the DI water. Some particle will be 1 minute. I have to charge my laptop. So remove. So clean or rough, porous or uneven surface. Treat a surface that is heat or chemically sensitive. Surface treatment that is easy to use and consist. So why we use the plasma? Removing organic impurity and contamination from the plasma can clean organic surface. Utilizing oxygen plasma surface activation take place resulting in the hydrophysibility maybe with make the H2O water molecules and water pump will be suck that molecules. So this is the plasma process. What is the plasma? Plasma is the ionized gas that consists of ions, electrons, neutral atom and molecules. So uh, in the if you appear for the UPSC interview and if you are from the engineering background or chemical background, they will be maybe ask the question that what you meaning by the plasma. Can you define the plasma and what is the application of the plasma? Okay. So plasma is the ionized gas that consists of the ions, electron, neutral atom and the molecules. So this is the energy of that oxygen we use the, as a plasma and they see that hyperperiplicity they make the H2O2, H2O molecules and this will be exhaust.
Yeah.
Some carbon will be there, then we will make the CO2 with the presence of that metals. So to ignite plasma uh, by an
Radio.
radio frequency, electric field and acquire energy to ionize the process of the gas O2 and 2 or argon. We can use that plasma. The energy of the plasma electron and ion are strong enough to ionize atom, break molecules apart from the reactive species, generate excited state, thus breaking down organic contamination on your surface. So जो प्लाज्मा जो बन रहा है जो एटम बन रहा है उसकी इतनी एनर्जी होनी चाहिए कि जो मेटल पे स्ट्राइक करे तब उसको उसको रिमूव कर सके सरफेस से.
Mm-hmm.
So see that this is the type of the plasma depending upon the process, gases and parameter. Plasma are capable of mechanical work through ion bombardment or chemical interaction with the radiation. या तो वो मैकेनिकली फोर्सली रिमूव करे या केमिकली वो उसके साथ रिएक्ट कर जाए और वो कुछ
Yeah.
बॉन्ड बना दे कुछ बाई प्रोडक्ट बना दे.
Oh,
So
yes, sir.
plasma can with the modified surface through ablation, activation, deposition, cross linking or grafting. So वो जो प्लाज्मा में जो मॉडिफाई करेगा सरफेस को तो वो टाइप ऑफ द एज पर द ऑर्गेनिक मेटेरियल की प्रॉपर्टी और आर्गन की एनर्जी पे डिपेंड करता है. वो एब्लेशन करता है या एक्टिवेशन करता है या डिपोजिशन करता है या क्रॉस लिंकिंग लिंकिंग करता है या ग्राफ्टिंग करता है. ठीक है
So
ना.
what is
एब्लेशन मीन्स
ablation?
रिमूव या
What is ablation?
एब्लेशन मीन्स वो उस मटेरियल को रिएक्ट करके उसका वो उसको तोड़ देगा. एब्लेशन में अलग अलग पार्ट कर देगा. ठीक है ना.
Okay. And activation?
एक्टिवेशन मीन्स वो उस जो आयंस है उसको एक्टिव कर देगा. इसका इलेक्ट्रॉन्स या होल्स है उसको एक्टिव करके वो रिमूव करेगा. ठीक है ना.
Ah,
उसको
okay,
कुछ
okay, okay.
एनर्जी देगा ताकि वो उसका जो जिस प्रेजेंट स्टेट में उसको रिमूव कर दे वो दूसरे स्टेट में चला जाए.
Ah, okay. So ablation is kind of mechanical and activation is kind of the changing the property of electrons.
केमिकल रिएक्शन टाइप.
Uh-huh.
ओके. सो मोस्ट
Mm,
कॉमन गैस शुड बी दैट आर्गन नाइट्रोजन आर्गन ऑफ हाइड्रोजन ये यूज करते हैं प्लाज्मा में.
mm. Yes, sir.
So safety constant that a plasma cleaner is a piece of electrical equipment, therefore it सेफ्टी डेंजरस होता है तो उसको लाइक दैट आर एफ वेरी हाई फील्ड होता है तो हम उसके अंदर उसके अंदर हाथ वाथ नहीं डाल सकते या कुछ भी नहीं कर सकते क्या वो, क्योंकि वो उसको इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड बहुत ज़्यादा होता है उसके अंदर। ठीक है।
यस सर।
ये देखो ये उसका है, ये गैस ऑक्सीजन गैस का चैम्बर है। तो टू इग्नाइट प्लाज्मा इट मस्ट बी अंडर प्रेशर, देयरफॉर बी अवेयर ऑफ द गैस प्रेशर। जो ये गैस प्रेशर है वो 10 psi तक ही जाना चाहिए उसके अंदर। अगर हाई प्रेशर देंगे तो उसका वैक्यूम टूट जाएगा और मे बी लीकेज के चांसेस ज़्यादा हो जाएंगे। जो अंदर वैक्यूम है जो 10⁻⁻10 या 2 है वो लो हो जाएगा, क्योंकि अंदर उसके अंदर गैस भरी जा रही है।
यस
ठीक है ना।
यस सर।
ये प्लाज्मा क्लीनर का पूरा चैम्बर है, ये देखो ये पूरा, ये वैक्यूम पंप होता है जो वो कंटिन्यू चलता है एग्जॉस्ट के लिए। ये प्लाज्मा क्लीनर है, ये सैंपल होल्डर देखने के लिए, क्वार्ट्ज का गिलास का है देखने के लिए। और इसको खोलते हैं, इसके अंदर हम वो सैंपल रखते हैं अपन इसके अंदर। ठीक है। और यहाँ से ये पूरा मैनुअल कंट्रोलर है, हम यहाँ से कंट्रोल करते हैं इसको। तो सी दैट ये देखो वेंट O2 फ्लो कराना है, यहाँ पे एयर फ्लो कराने के लिए है, ये कुछ के लिए नहीं, ये 3 इनलेट है वेंट करने के लिए। और यहाँ पे ये अंदर ये एक सेंसर लगा होता है जो प्रेशर मेजर करता है कि इसके अंदर कितना प्रेशर है। और ये RF पावर देने के लिए यहाँ पे है, और ये पावर कितना वॉट का आप देना है, कितनी पल्स टाइमिंग देना है, वो सब ये सारा मैनुअली यहाँ पे अपन इंटरफेस है अपने।
हाँ।
यस
यस सर।
ठीक है। तो ये देखो जैसे ही हम रन करेंगे तो रेसिपी रन हो जाएगी, रन जॉब हो जाएगा। स्टॉप करने के लिए आप वेंट करने के लिए वेंट करना है तो आप गैस बंद कर दो, वो गैस बंद कर देगा और वेंट कर देगा, पूरा पूरा वैक्यूम रिलीज कर देगा। पंप डाउन करना है, ऑटो ट्यून करना है, रेसिपी सिस्टम, ये सारा ये एक सिस्टमेटिक बोले कि ऑटोमेटिक सिस्टम है, टच पे सिस्टम है, यू हैव टू फीड लाइक कंप्यूटर सिस्टम है। सो दिस ये आउटलेट पीछे का ये चैम्बर है। सी दैट ये गैस के लिए, ये पाइप लगाने के लिए गैस के लिए 3 पाइप लगा सकते हो। ये वेंट का पाइप है, और ये सब सप्लाई वगैरह ये सब। ये पंपिंग है, वैक्यूम पंप के लिए है। ये पंप का पावर का इनपुट रेट है, ये सारा कुछ ये फैन लगा हुआ है उसको कूल डाउन करने के लिए मशीन को। और ये लॉग बुक में कोई लोग जैसे वो एंट्री करते हैं कि हाँ ये लॉग बुक मेंटेन करना होता है ताकि किसने क्या का कौन सा ये वाला। अब हम पिछले क्लास में तुम्हें डाउट था व्हाट इज द सेंसर, व्हाट इज द IR सेंसर, हाउ IR सेंसर वर्क, आप उसको ऑर्डिनो से कैसे इंटीग्रेट करेंगे, IR सेंसर कहाँ कहाँ यूज होता है। So that's with a sensor is a device which is used to sense the surrounding of it and give some useful information about it. Like that pressure है तो pressure sensor यूज करेंगे, लाइट का है तो लाइट के लिए IR सेंसर यूज कर सकते हो, UV सेंसर यूज कर सकते हो, ह्यूमिडिटी मेजर करना है तो ह्यूमिडिटी सेंसर मेजर कर सकते हो, टेम्परेचर के लिए टेम्परेचर सेंसर यूज कर सकते हो। तो बहुत सारे सेंसर आते हैं। कैमरा के लिए इमेजिंग सेंसर यूज कर सकते हो कि कैमरा की इमेज लेने के लिए। ओके।
यस सर।
सर सर
यस।
सर अभी मतलब सेपरेट सेंसर्स तो मतलब आ नहीं रहे हैं, कॉम्प्लेक्स सेंसर्स फॉर्म में आ रहे हैं। जैसे कि एक सेंसर में बहुत सारे फीचर्स मतलब वो
हाँ तो
प्रोवाइड कर रहे हैं।
people are working that like that they have to choose the materials which give the everything, like that you are working in the optical. Okay.
या या
So you the choose the material which also sensitive to light also, that also sensitive to gas also, that also sensitive to temperature also.
ओके।
Okay.
So they are not different sensors. They are different. They are character of one material which has different parameter.
Yes, so we use the like IR sensor, infrared sensor. So IR is the no how to make the IR sensor. You either use the silicon or germanium.
Yeah.
That are the property they are detecting because if you read the formula, your band gap should be greater than equal to 1.24 upon lambda.
One. Yeah.
Okay, lambda is the wavelength of light,
Yes, sir.
and your band gap, the silicon is like that 1.1 electron volt band gap.
ओके।
Yeah.
So if you divide 1.1, that how much the wavelength will become? It is around above that 800 nanometer or 700
Okay.
nanometer. And 700 and 800 nanometer should be case in the IR. This is IR wavelength light.
Okay.
यस सर।
Okay. If you choose the material, see that if the material has the band gap of 2.5 or 3.1. Okay.
Mm.
or 1.6 or 1.9. It may be broadband. It will be also detect the IR and visible both.
Okay, okay.
Okay.
Yes,
Yes,
sir.
sir.
So it's depend upon your requirement that where want you to use that sensor. If you want to use for the particular applications, you design the sensor can be for selective for the particular application only.
Mm.
Suppose that you want to detect the H2S gas. Okay,
Hmm.
you use the sewage line. Have you seen the sewage line? Sewage,
CV? Yes, yes.
sewage like that. The sewage, the waste material.
Yeah.
Waste material. They have when they have the decomposer react. They have to release that CO2, CO, H2, NH3. Many gases will be present in the sewage.
Sewage line. Hmm.
And what will happen that people are see that the people are go in the sewage and they are die due to the ammonia.
Mm.
You see
Yes,
the
sir.
many news in that newspaper.
Yes, sir.
So you have to make the design that sensor that detect that concentration of the ammonia in the sewage. Only ammonia.
Okay,
So what
okay.
you have to take the material that detect the ammonia, and you have to fabricate the ammonia sensor, and you can connect it to the IoT devices or some integrated system, and you can see on your phone. And you put the sensor in that sewage, and you can calculate in the phone that this concentration will be available. This is very harmful. So you have to
Okay.
either take the protective. You have to protect yourself to enter the sewage line before.
Okay.
Okay. So you have to wear the oxygen cylinder and mask. That mask that will be not enter inhaling during time, and you can protect yourself. But people are go in the drainage system without any procurement and any know that how much the concentration, and they will be die.
Yes.
Okay,
Yes,
like
sir.
that. IR sensor will be used in the imaging, obstacle detection. Okay, you have to focus the like that in the like that you see the Mercedes car Mercedes or BMW. They are use the
Mm.
IR sensor. In the front of that, they have the focus. In any obstacle will become that light will be reflected back, and it will be sensed that there will be some obstacle will be there. So you have to aware that there will be some truck or some animal will be moving. So you have to speed down or you have to take care about that.
Yes, sir.
Like that,
So,
if you are in your car, there is a backside sensor that will be when you take the back in your image will become here that there will be no in the back. When you
Mm.
yes.
reverse
Yes,
your
sir.
car, you can see the display on the car that the backside image. Have
Yes,
you
sir.
aware about that?
Yes, sir. Yes,
Yes, sir.
sir.
So that will be possible to the IR sensor only.
Ah.
So they are specified sensors
Yes.
for specified person for specified work.
For specific application that. Okay. Like that in the space, if you use the rocket or satellite, you check that if the people will move in the space or like that flame detection or if there will be fire in that in the rocket or anything and people are sitting that how can we take that there will be fire outside. That
Sir,
sensor will be
for
that only detect only that fire only because in the there is a lot of parameter will be in the atmosphere.
Okay.
Okay, but you have to particularly application you need to take up that.
So what is the meaning of smart sensors?
Smart means what you mean by the smart? When you remove the sensor, what you understand by the smart?
I think smart means the sensor which is more capable, more sensitive. Uh, the physical
Suppose,
characteristic of the
suppose,
sensor is much
suppose you
better.
are suppose give the example. Suppose you are sitting in the class,
Yeah.
eh? Your faculty will be told that this boy is very smart. Means why
Uh,
he said that this boy is very smart or this girl is very smart and intelligent.
the performance of the boy or girls is much better than any other person in the
Others
class.
means this is very fast. They are responding to everything. They are understanding everything.
Okay.
So your sensor should be smart. Means your sensor should be response time should be very less in the microsecond. Like your brain. Your brain should be smart.
Mm. Yes,
Yeah.
sir.
Suppose that you are cooking some food. Okay.
Yeah.
And unfortunately you have to touch your that untils that are very hot. Your brain should be very smart. It will be in the picosecond. It will sense that your brain should be. Your hand will be put down. You take a head very fastly pulled take away from that untils. Have you
Yes,
faced
sir.
that problem? Have you experienced that things?
Yeah,
Yes,
yeah,
yes.
yeah. Yes, sir.
Same type of sensor you want that it will be very fast and responding to particular things only.
Ah,
And
okay.
it will be so your in mobile that is your smart that you in your hand your watch should be that capable that these things will be happen.
Mm.
So you have to be
Mm.
integrated with the smart things. You have to integrate with the processor system.
So we
Yeah.
can say, sir, our mobile phone is called smartphone because of the lots of sensors in our mobile.
Yes, your mobile phone is smart because it gives all the information to you
In a less amount of time.
in less amount of time.
Mm-hmm.
You need a Google, you need a Google. You need a network, you can calling. You parallel, you do the WhatsApp through the calling. You parallel do the chatting. You parallel browsing something. You parallel get the information. That's why this is smart because it will be used for the many applications.
Yeah, yeah. Same device,
Okay,
many
okay.
application.
So same device you want, your device will be give
Mm.
the information in a very fast manner.
Ah, yes, sir.
Hmm?
Yeah. Yes, sir.
Mm-hmm. Yes,
That's why
sir.
smart technology means smart technology. What meaning smart technology? Your technology is very fast and efficient, and efficiency is very high.
Okay.
Yeah. Yes, sir.
Okay.
Yes, sir. Yes, sir.
So this is the IR sensors. This is the visible and this is the infrared. NIR, standing wave radiation, microwave, long wave, very long wave. Okay.
Hmm.
So this is the visible spectrum of the lights, that solar spectrum that you have to divide that light in the particular wavelength. That visible light have the particular wavelength. That green light should be that wavelength of around 600 nanometer. Red should be 650. IR should be 700 nanometers. So that will be that there in that whole source of that solar energy have the some spectrum of light, and it have the particular wavelength that UV should that UV light should be 365 nanometer, deep UV should be 280 nanometer or 100 nanometers. Okay, so IR
Yes.
should be start from the 700 nanometer to 1500 nanometer. So 700 should be the near infrared light and 1500 should be far infrared light. So you have to distinguish that which light you want to use, and according to that you have to fabricate your sensor materials, choose your materials, device.
Mm. Yes, sir.
So different type of IR sensor that radiation thermometer, that IR sensor I use the radiation thermometer means radiation light, and it have the temperature also to measure the temperature depend upon the temperatures. Means you use the material who have the capture that sensor that when this material will be heat, it will give what amount of the heating will be done, it will be capture that. Okay,
Yes,
in
sir.
presence of the radiation. Means some X-ray will be fall on the your material will be heating in presence of the X-ray and it will be give the temperature. That temperature of the material should be around 100 centigrade, 200 degrees Celsius or 500 degrees Celsius. And whatever the intensity of that radiation, you know everything that this intensity, if I given that 5 electron volt of the ray and your temperature will be 100 degrees Celsius. If you given the 100 electron volt, your temperature will be rise around 30 degrees Celsius. Okay, so you have to calibrate that things, how your instrument you have to calculate, you have to calibrate your sensor also.
Mm. Yeah.
A flame monitor, it will detect the flame or burning of the light also, flame sensors. A proximity sensor, touch screen sensor, this is the proximity, your touch screen will be proximity, pressure sensor. When you press or something that it will be give the signal and it will be open, or some number will be touch on that touch through the touch screen.
The
Gas
Mm.
capacity based
analyzer
sensor.
that use the absorption of the gases H2S, CO2, toxic gases, oxygen sensors, PIR sensor for automatic door opening. In the metro, you see that automatic door will be open. How that door will be open in the mall and everything? that light will be fall on the any obstacle will be see, light will be fall, it see that obstacle will be there. So you have to coding on that Arduino system that if the obstacle will become, the door will be open, otherwise it will be remain the closed. So it will be just you have to do the IoT enable or machine learning enable your device.
Mm. Yes, sir.
Okay.
Yeah.
So this is the circuit diagram of that IR sensors. So if you want to do the with the, you take that one LED you have to require that generate the light. This is
Okay.
the resistance. This is LM35. It is IC, and through that you can make the IR sensor in the
Oh,
breadboard also. If you have the breadboard, you need this component and you will make the IR sensors.
yes, sir.
Suppose that you want to obstacle the things. When some obstacle will come in front of that LED, the light will be reflected back. Okay? So your
Mm-hmm.
signal will be more.
Yeah.
Okay? So it means you have to do the coding. If the light will be reflected back, door will be open. Otherwise, it will be closed in your coding. Arduino.
Okay. Yes, sir.
So this is the component you need to fabricate that IR sensors. This component. Okay?
Yeah.
So this is a working principle. When IR sensor does not receive the signal, the potential at the inverting input goes higher than non-inverting input of the comparator. So use the comparator IC that compare the signal of the input and output.
Mhm.
Okay.
Okay.
So when the potential at the inverting input goes higher than non-inverting input of the comparator, when the, we have to not receive any signal. Okay. If you receive the signal, this means that on in non-inverting mode you give the more signal. Then if you check that if inverting non-inverting input is more, your door will be open. Otherwise, it should be the closed in the coding. So okay.
Yes,
Yes, sir.
sir.
So this is the working that of the all the sensor. We see that this we have to mount it everything.
Yeah. Yeah.
Okay.
Yes, sir.
So this is the Arduino connection. How we connected to the Arduino. So see that we take the output only that through the Arduino, and it will control.
Yes, sir.
So this is the fabrication of the microfluidic devices. You have to ask me the first time that questions. So this is on the paper that see that how that deposition of the photoresist will be there. This is silicon wafer. Okay. Then we have
Mhm.
to deposit this channel through that UV lamp in the photoresist mask, and see we have to develop this microfluidic channel here through the photoresist
Yeah.
etching and everything that.
Yeah.
Then we have the deposit of PDMSs here. This is the organic material, the polydimethyl. I have to forget that full form. So we can
Sir,
transfer that.
polydimethyl siloxane.
Yes, yes. Okay.
Mm.
Then
Mm.
this is we put in the plasma chamber to etch everything that impurity and everything in the plasma or to dye that surface that. And this channel will be made this type of channel. This is the
Mm.
same images. This is the schematic diagram, but this is actually we have to fabricate it on the
Ah,
devices.
yes, sir. Yes, sir.
Okay.
Yeah.
Yeah.
So why we use the PDMS, use the fiber micropoly, this is a polydimethyl siloxane called PDMS, or dimethyl is the polymer widely used for fabrication and prototype of it is a mineral organic polymer of the selection family, alkyne family that we use. PDMS we can use to uh, this is the sticking coefficient we use. Okay. So when we want to sticking some materials on that, when we have the materials that surface that is sticking, we use want more sticking. If you want to remove through that some layer, you first deposit PDMSs, then you have to make that like that in the silicon oxide. You deposit some metal ZNO oxide, ZNO, and you want to remove that ZNO layer from the silicon oxide. So you have to deposit PDMS or PMM layer on that materials, and then you move in the chaos solution. Your ZNO layer will be flow on that chaos solution, and silicon will be shut down on the bottom. So you can transfer the layer also through that also that. So this is the application that you. Thank you. Anything else? Any questions
No, no, sir.
regarding subject, personal, professional? You can ask me.
Regarding the subject, there is no
Huh?
questions. No questions, sir.